Hi guys, in the previous video we discussed what is solution and what is suspension. In this video we shall learn what is colloidal solutions, right? So for that I want you to understand various substances like milk. If you take a mixture of salt and water, you will definitely say it is a solution. Then if I take a mixture of chalk powder and water, then you will definitely say it is a suspension. Then what about milk? Milk, is it a solution or is it a suspension or is it a colloidal solution? If you look at milk, I have some questions for you about milk. The questions are, in the milk there are particles. These particles, are they evenly distributed in the milk? You would answer would be yes. Right? And can you see the particles of the milk? Can you see the smaller particles of the milk? No, you cannot see the particles of the milk. And my question to you is also that if you take this milk, the particles of the milk, when you keep the milk for 2 or 3 hours, are they going to settle down? They are not going to settle down. It looks like they are uniformly distributed and they are very small in size and they are not going to settle down, right? So there are so many mixed aspects are there with regard to milk, right? So when I say milk is not a solution and it is not even a suspension, but it is a colloidal solution. So what do we mean by a colloidal solution? For example, milk is a colloid. That means it is a liquid which is dispersed into liquid. I will come to that. Then again, one more example is clouds. Your clouds that are formed in the sky, they are also example for the colloids. Then fog, the mist, the smoke, the shaving cream, all of these are all example for the colloids. So, what do you mean by colloids? So, colloid, just like solution, has two parts. One is a dispersed phase and a dispersion medium. Dispersed phase and dispersion medium. This is like solute-like component. What is this? Solute-like component, whereas the dispersion medium is a solvent-like component. Right? So, in a solution, the salt is dissolved into water. Right? So, if you take a colloid, the solute-like component is called dispersed phase, and a solvent-like component, that is which is present in the larger quantity, that is called as dispersion medium. So here, if you take a milk, the particles of the milk here are in the form of a liquid. So liquids are dispersed into the liquid. If you take milk, the liquid is dispersed into liquid. Liquids are dispersed into liquid. If you take clouds, what are clouds? Clouds are what? From clouds, what are you going to get? You are going to get the rain from the clouds, right? So basically, what the clouds are having or holding, the clouds are holding the water molecules, right? So you can say the water molecules are dispersed in gas. So gas is acting as a dispersion medium, just like a solvent. So I'm going to just write liquid in liquid, and here, if you look at clouds, you can say the liquid is there in the gas. Right? Similarly, fog and mist, these are all the liquids are present in the gas. If you look at smoke or dust, right? So this smoke, which is produced by the vehicles or the exhaust of the automobiles, you can see that this smoke is basically solid, but it is dispersed in a gas. That is what if you look at the shaving cream, in the shaving cream, what you have is a gas in solids. What you have is a gas in solids. Okay, that is shaving cream. So from all of this, I think you understood the meaning of what is a colloidal solution or just a colloid. So then what are the different properties of these colloidal solutions? Let us discuss one of the properties of colloidal solutions. The first and foremost property of these colloidal solutions, as you are thinking, it is not a homogeneous mixture, but it is a heterogeneous mixture. Colloidal solutions are heterogeneous mixture. That means the composition is not uniform throughout the mixture. Second one, you cannot see the particles of the colloidal solutions with your naked eyes. Too small, but you cannot see them with naked eyes. Then, do they scatter beam of light? Do they scatter a beam of light? So, I want you to understand the particles. The particles are too small and cannot see them with your naked eyes, but they are big enough. They are big enough to scatter a beam of light. All of you know the scattering of light, right? So whenever a beam of light hits any particle, the light is going to get scattered. The light is going to get scattered in all the directions. This is scattering of light. The incoming ray of light is going to hit the particle and it is going to be scattered. Right. So therefore, what happens is, if you take a colloidal solution, for example, milk is a beaker and this is milk. If you take milk, a colloidal solution, so you just put a source of light here. Please put a thin, narrow beam of light. Then these particles, even though the particles of the colloid are very small, they are big enough to scatter a beam of light. So when these are going to scatter a beam of light, you can say the path of this light becomes visible. You can say they are big enough to scatter a beam of light. So because they are going to scatter a beam of light, so the path in the solution is visible. So path of light is visible. Right? So this particular effect, the scattering of light by colloids, is known as Tyndall effect. Scattering of light by colloids is known as Tyndall effect. It's known as what? Tyndall effect. I think you must have observed this Tyndall effect everywhere in your surroundings. For example, when a thin narrow beam of light enters your home through a hole, you can see the dust particles will be visible. That is the scattering of light by those dust particles. Whenever you enter a cinema hall, then from the projector screen you can see that the Tyndall effect is observed. The dust particles present in the cinema theater are going to scatter the beam of light and the Tyndall effect becomes visible. Here also, if you take a source of light, here also the particles are going to scatter a beam of light, then the Tyndall effect is observed. The Tyndall effect was first observed by the scientist Tyndall, so in his honor, in his name, this effect is given. Also, when if you look at the trees in a forest, then the sunlight comes through a canopy of the trees. There also you can observe the Tyndall effect. So Tyndall effect is basically the scattering of light by the colloidal particles. Right? So that is Tyndall effect. So now, what about the filtration or the suppression technique? Can you use the filtration method to get the particles of the colloids? No, because the particles are too small and therefore you cannot use a filter paper to separate them. Can you do it by evaporation? Obviously no. There is a separate technique called centrifugation. This technique is called what? Centrifugation. This technique is used to separate the particles of the colloids. Right? For example, if you take a milk, if you want to separate the cream from the milk, you are going to use this centrifugation process. And also, if you want the butter from the cream, that time also you are going to use the centrifugation. Right? So this process is used. Centrifugation is used for the separation of the colloidal particles. Right? So this is about colloidal solutions, guys. So I think you have understood. Milk is a colloidal solution. Cloud is a colloidal solution. Shaving cream is a colloidal solution. So many colloidal solutions are there. It means one dispersed phase will be there and one more dispersion medium will be there. Dispersed phase is dispersed in the dispersion medium, right? Just like solute is dissolved in the solvent. Here, just we are giving a different name. It is a dispersed phase is dispersed into the dispersion medium. Okay, so that is what makes the colloids, and colloids give the effect called thinner. Okay, I hope you understood the different properties of colloidal solutions. Okay, thank you.